Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 2, Section 2, Solving Two-Step Equations. By the end of this video, you will have reviewed methods for solving two-step equations and using deductive reasoning. In the process, you will solve a two-step equation. You'll be multiplying by -1 to solve equations and using deductive reasoning in a couple instances and solving real-world problems. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to the channel if you find this video to be helpful. Subscriptions will definitely help me. Thank you. Bye-bye. Objective 1A. There's going to be multiple slides for this Objective 1. Solving two-step equations. There are basically two steps one needs to follow when solving an equation. The first step is to get the variable term alone on one side of the other equation using the properties of addition and subtraction. Okay. Then you need to isolate the variable from its coefficient. And that coefficient is anything other than the coefficient of 1, because you can never get rid of the coefficient of 1, but you have to be at that point. Coefficient of 1. Use the properties of multiplication and division. See the summary below. So it says solving two-step equations. Step 1, use addition and subtraction property of equality to get the term with the variable alone on one side of the equation. That's all the constant terms are on one side, and that single variable term, there could be multiple variable terms, but you want to get one eventually, on the other side. Okay, you're getting it alone on one side of the equation. Then use multiplication or the division property of equality to write an equivalent equation in which the variable has a coefficient of 1. So that's kind of what we said above, and that still holds true. Okay, example 1, solving a two-step equation. So what is the problem? It says solve 10 equals m divided by 4 plus 2. Okay, so let's look at this thing. We have all the steps in front of us, but let's see if it follows what we talked about in the previous slide where it said step 1, step 2. First, get the variable alone by itself on one side and all the constants on the other. And then when you're done with that, then remove the coefficient, eliminate the coefficient or free the variable from its coefficient, okay, to solve for the variable. So let's see what we're doing. In fact, right here, we're going to say we've got 10 is equal to m divided by 4 plus 2. So the first thing we have to do is this first step, which is subtract 2 from each side using the subtraction property of equality. That's what we're doing here. And when you do that, it means you add a -2 to this side, and then you add a -2 to the other side. Because remember before we talked about the scales that had to be balanced all the time. Okay, so now we've done that, right? So now that we've done it, we have to simplify. And simplifying means you add the plus and -2, and that's going to give us 0. And on the left-hand side, 10 minus 2 is going to give us 8. So we end up with 8 equals m divided by 10. As you see, the 2 over here is now gone. It was now combined with the 10, which gives us now 8 because we subtracted 2, because we had to subtract 2 from both sides. So now we have 8 equals m divided by 4. Well, what is the coefficient of m? Well, if you don't see it right off, the coefficient is 1/4, because this m is written m times 1/4. And so here's the coefficient right here of the m variable. Got it? Okay, so given that, we're going to take, how do you do that? We either have to multiply or divide. What we're going to do is we're going to multiply using the multiplication property of equality both sides by 4, because the way you get rid of a 4 in the divisor here is by multiplying it 4 in the numerator. 4 over 4 gives you 1. So then the coefficient of the m variable is now 1. And when you multiply one side by 4, you have to multiply the other side by 4. So here we have it, 8 times 4 is 32. Our answer, m equals 32. Okay, example 1, check your understanding. If you've been here with us at this channel before, you know that when these types of slides come up, I'm asking you to pause the video, try these problems on your own, and then when you come back, we work them together. So I'll read them off to get us going here. It says solve two-step equations, and check your answers. Okay, so the first problem is 7 equals 2y minus 3. The second problem is 6 times a plus 2 equals negative 8. And then finally, on this, the problem C, x divided by 9 minus 15 is equal to 12. So why don't you go ahead and see if you can work these, stop the video, work it, and then when you come back, we'll try to work them together and see how it turns out. Okay? I'll wait. Okay, I'm assuming you stopped the video. I'm hoping you did. I'm sure you did. So let's go ahead and try and work some of these on our own, okay? So the first thing we do is we're going to do problem A. And what did it say you had to do? Step one was remove the constant terms, right? Or move the constant terms to one side and the variable terms to the other. It doesn't matter which side you choose. I usually choose the side that's easiest, and you'll learn that as you go along. What easy, if you don't have to move the variable, don't move it, right? Move all the constants. It's kind of my thinking. So let's start off. The first thing we do is we want to get the 2y by itself. It's on the right side. So let's move the constant, the negative 3, to the left side. And to do that, what are we going to do? Well, I'm going to write the problem. 7 equals 2y minus 3. Okay, so now to do this, we're going to add negative 3 to both sides. So now I'm going to say negative 3 is a positive 3 you have to add. 3 plus 7 equals 2y minus 3 plus 3. So we've added using the addition property of equality. We added plus 3 to both sides. Then these 3's cancel. That's what we intended. And then we're going to complete this over here, which 3 and 7 is 10. So now we have a 10 equals 2y. So now we have to solve for y. And it said we have to now, the step is to clear the variable of its coefficient so that you have a coefficient of 1. In order to do that, we have to multiply by 1/2 because 2 divided by or times 1/2 is 1. And that'll make so what we're going to do is we're going to say, and we're going to do a half on both sides. In other words, it's dividing by 2, right? So we're going to say, or 1/2, so I'm going to say 1/2, oops, 1/2 times 10 is equal to 2y times 1/2. And now the 2's cancel, and you're left with a y equals 10 divided by 2 is 5. So 10 divided by 2 is equal to 5, and the 2's canceled, so y is equal to 5. So now if we check our answer, we're going to go back up here, and I'm going to say 7 equals 2 times, we're looking for a 5. So I'm going to place a 5 in here. Oops, 5 minus 3. So now if I take and solve this, I have 7 is equal to 2 times 5 is 10 minus 3, and 7 is equal to 7. Check. Got it. How about B? Again, we have to get the variable term by itself. We're going to do this one and keep it on the left-hand side. So we're going to say 6a, I'll rewrite the problem, plus 2 equals minus 8. I always do this, and then as I'm writing them, I'm thinking about what the problem is. I'm kind of ingraining it into my memory, and I'm trying to know the pieces. And I also look to say, is it the same as the problem that they've asked me to solve? And yes, it is. So the first thing we do now is get the variable term by itself, which we're going to use the subtraction property of equality to do this. So we're going to say 6a plus 2 minus 2 is equal to minus 8, or negative 8, minus 2. And these 2's will cancel. So I'm going to have 6a is equal to negative 8. Negative 2 is going to be a negative 10. I added minus a negative 8 plus a negative 2. So now I'm going to get what? If I divide both sides, the second step is divide to get rid of the coefficient. make the coefficient a 1. To make this coefficient a 1, I'm going to divide this by 6 and divide this side by 6. And when I do that, I'm going to get a is equal to negative 10 over 6. And what does negative 10 over 6 equal? Well, if I say 10 divided by 6 is going to go 1 time, and I'm going to have 4 remainder, so that's 4 sixths. 4 sixths, which equals negative 1, 1 and 2 thirds. Okay, and negative 1 and 2 thirds, if I put a negative 1 and 2 thirds into our 6 here, let's hopefully have enough room. 6 times, I'm going to go back to the negative 10 sixths. Negative 10 sixths, okay, plus 2 equals negative 8. So what is 6 times 10? 6 times negative 10 is 60. Divided by 6 is 10, right? So is 10, okay, I'll go with this, plus 2 is equal to negative 8. So now I have to get, I have to move the 2, right? So I'm going to have to move the 2 over, and I'm going to get a 10 plus 2 minus 2 equals 8 minus 8 minus 2. I did something wrong here? Negative 10. Let's figure out what I did wrong. Negative 10 here. So this is negative 60 divided by 6 is negative, oh, negative 10. Sorry. I know I had a mistake here. Negative 10. Now I subtract the 2, negative 10. And then I'm going to get negative 10 here, negative 10. These twos cancel, and I'm going to get negative 10 equals negative 8 minus 2 is negative 10. Okay, see, that's why you check. I had a mistake in my answer right away. That's a perfect reason to check. Oh, my check didn't match what I thought I had. And we found out that I messed up and didn't carry the negative 10, the negative sign down. Okay, how about that? So now let's do this one. X divided by 9 minus 15 equals 12. So we're going to have to get the 15 and move the 15, right? That's step 1. Get the variable on one side and the constants on the other. So I'm going to have x divided by 9 minus 15 plus 15 is equal to 12 plus 15. So now these cancel, and I have x divided by 9 is equal to 12 and 15 is 27. 27. Now I multiply, I have to get rid of the divisor here, this 9 in the divisor, so I have x by itself. And I do that by multiplying by the multiplication property of equality. I can multiply both sides by 9, and that's what it means. I can multiply both sides of the equation by anything I want as long as it's the same thing. I can multiply each side by 1,000,000 if I want. It's not going to change the answer. Okay, so I'm going to multiply this side by 9 and this side by 9. And when I do that, I'm going to get x equals, well, 27. Let's see, what is that? 9 times 20 is what? 2 to 18 is 180. So it's 180 plus 9 times 7 is 63. So 180 plus 63 is equal to 243. So x is equal to 243. And if I check it, if I say 243 divided by 9 minus 15, is that equal to 12? So 243 divided by 9, what is that? It's going to be, what is that? Let me get the calculator out. 243, is it easy? Maybe it's easy and I should know it off the top of my head, right? So let's get back to the calculator. Calculator says 243 divided by 9. Is that it? 9 is 27. Well, I should have known that. Here it is right over here. 9 times 27, right? Sorry, I should have known better. Is equal to 27. So 27, right here we go. So 27 minus 15 is equal to 12. And 27 minus 15 is equal to 12 because 12 times 12 plus 15 is 27 equals 12. So there you have it. Okay, that one's solved. Okay, objective 1B, still we're solving two-step equations here. Let's talk about it a little more. You can write two-step equations to model real-world situations. Some real-world situations require whole number answers. So what that means is we're going to come up when we're going to do some mathematics, and it's going to be some fractional number like 62.3, okay? So it won't be 62, the whole number. But when you're in the real world, you can't have like, what if you're talking about how many people are allowed to go to the fair or get on the bus? You can't say, oh, 35 and a half people can get on the bus. You have to say, you have to round it down and say 35 people can get on the bus, right? So that's what they're implying here, require whole number answers. So check that your answer is reasonable for the given situation. No fractional items, people, books, cars. You can't have half a car, whatever it is. Okay, if it's an item, you can't necessarily have a half of one without cutting it in half, which probably doesn't make sense. They're not allowed. Okay, so let's see what the problems are going to give us. Okay, example 2, a real world problem. Okay, you are ordering tulip bulbs from a flower catalog. You have $14 to spend. Use the catalog page at the right to determine the number of bulbs you can order. Okay, we have a picture of it down here, and it says tulips. Take advantage of our high quality, blah, 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 blah. One bulb for 75 cents plus $3 shipping. That's the cost to order them, okay, online or have them shipped to you. 75 cents per bulb and $3 shipping. So let's put that into those words into a formula, some kind of a formula, okay? So let's relate cost per bulb times the number of bulbs plus the shipping costs equals the amount that you can spend, because we know what the maximum that person can spend is $14. So there's our equation in words. Now we're going to let B equal the number of bulbs. B sounds like a good for bulbs, okay? And it's the count that we're going to look at here. And now we're going to write this equation in numbers and variables. So the cost per bulb, 75 cents. I could put a dollar sign right there, right? 0.75 times the number of bulbs, times right here, see it, times the number of bulbs, B, plus $3 for shipping. And that, all of that cannot be greater than 14, because that's all you have according to this problem. It says you're ordering the bulbs. So all you have is $14. So now let's do the math. We're going to rewrite this equation more like an equation. So 0.75 times B, and there's a times there. I didn't put the B right next to it, but it's implied, I guess, at that point. There's a little dot right there. 75 times B plus $3. So it's 75 cents per bulb times the number of bulbs plus $3 has to equal to or be less than, right? Less than or equal to 14. Well, we're not going to talk about inequalities yet, but it has to be 14 or less. So 75 times B is so plus 3 minus 3. We've done that a number of times. And a negative 3 over here on the other side. Got a negative 3 on both sides to get rid of this positive 3 right here. We have to get rid of that. So now we have $0.75 or 75 cents per bulb, and we have $11 left. So now if we divide both sides by 0.75 to get the B by itself. We want to know how many bulbs we can buy. We're going to have to multiply by the division property of equality. So we're multiplying by 1 over 0.75. And here it is, 1 over 0.75 times 0.75. Those are going to cancel, become 1. And then we'll be left with our B. And that is equal to 11 times the quantity 1 over 0.75. And when we simplify it, B will be equal to 14.6 bulbs. So here's that thing we talked about. Can you have a 0.6 bulbs? Does that make sense? No, so you can order 14 bulbs. So you'll see that come up quite often in your problems that you have to round down. Usually hardly ever round up unless you're told to. In the real world problems like this, it's usually you're rounding down to a whole number. Okay. If you're going to buy tires, how many tires for your car can you buy? You're not going to buy 4.5 tires or 3.25 tires, right? Okay. Okay, here now, example 2, check your understanding. And as you now know, that means I'd like you to stop the video and try this on your own. Suppose the tulips are on sale for 60 cents per bulb. What number of bulbs can you order in that case? Remember, you have the equation. You can back the video up to go see it. But if you remember, the previous equation was, I'm going to write it right over here. It was 0.75 B plus 3 equaled $14. Now that I've given you that, go ahead and you can now figure this, get the answer, okay? I'll wait. Okay, now that you're back, so you know the tulips are now 60 cents per bulb. How many bulbs can you order? Well, there's the equation. It's the same equation as the last time with one difference, right? What was the difference? I wrote it out for you. Instead of being 75 cents, it's 60 cents. But our original equation for this problem is this one, 0.6b plus 3 equals 14. So we're going to start off like before. We're going to get rid of the 3 on the left-hand side and move it to the right-hand side. In order to do that, we have a positive 3. We have to add a negative using the subtraction property of equality onto both sides, adding a negative 3. When we do that, these 3's will cancel, and you're going to end up with 0.6b equals 11. 14 minus 3 is 11. We're at the same $11 range. But now, instead of multiplying both sides by 1 over 0.6 to get rid of the 0.6, by using the division property, okay, of equality. Actually, it's multiplying by a fraction, but if I put this underneath, it'd be division. It's kind of confusing, but you could call this multiplication property of equality, and you're multiplying by 1 over 6.6. Both sides get multiplied by 1 over 0.6. And when you do that, you're going to get B is equal to 18.33333. That's forever. I put the dot, dot, dot. It's easier than me trying to find a little line and put it above the number. So when you see the dot, 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 that means something here is continuing. And I'll show you the repeating pattern of what's repeating. So how many bulbs can we buy? It says 18.333 bulbs. Well, you can order 18, right? Rounding down to an even number of bulbs. Okay, good. I think you've got that. Okay, now we're going to do objective 1C. This is the third slide in our first objective, solving two-step equations. So in some equations, the variable might have a negative sign in front of it, okay? Such as negative x equals 3. To help you solve these equations, recall that x equals 1 times x. And negative x equals negative 1 times x. That's just all you have to know that. Is that negative sign really, really always means negative 1. And you can, anytime you see a negative sign, you can always replace it like multiplying like this, or that's basically what you're going to have. It's got to be in the multiplication scenario, but it means negative 1. So you can solve for x by either multiplying or dividing by -1. And you can multiply and or divide, it's not going to make a difference because it's 1. 1 is unity, right? You can divide by 1, you can multiply by 1, you can multiply by 1 over 1, it's still 1. No matter what you do, it's always 1. Okay? And you can multiply and divide by -1 to get rid of the -1 that you don't want. So here we are at example 3, multiplying by your -1. So now you're going to see a case for it. So we have solve, right here, solve negative b, or minus, I'll say negative b, plus 6 is equal to -11. So rewriting the equation, I rewrote the equation just to make sure I'm dealing with the right problem. And then I say, oh, well, I need, as before, I need to get the 6 away from the variable. So I have to, using the subtraction property of equality, I'm going to get rid of the 6. And to do that, I'm going to say negative b plus 6 minus 6 is equal to -11 minus 6. Both sides I multiplied, or not multiplied, excuse me, I added a -6. That's what I'm doing. I'm adding a -6. I'm not saying subtraction. I did here in the form, but I'm really adding a -6. It'll help in the future if you think that way. And then what you end up with is the b over here by itself, negative b, is equal to -17. So what do I have to do to get rid of the negative? Just what we said in the previous slide. We can multiply to get rid of this negative right here. We can multiply by -1. So I have negative b, which this is that -1 right here under with the b. That -1 is in there, kind of hidden, right? We talked about it. It's given that it's -1. We're going to multiply both sides by -1. So we're going to multiply the negative b by -1 and the -17 by -1. And then what's going to happen? -1 times -1 is 1. So here we have 1b, and I can and always do remove the 1 and positive 17 because the -17 times -1, negative times a negative is positive. So b is equal to 17. Okay, example 3, check your understanding. Excuse me, since you've been with me for a while now, you know that this means you should stop the video, get a piece of paper and try these problems. And then I'll pause and wait for you. When you come back, we'll do them together and see how you did and see if I can get through them with you. I make mistakes too sometimes, as you've probably seen in the past. Anyways, solve each equation. I'll wait for you. Okay, so here we go. We're going to solve each equation, and we know that what we're dealing with here is that -1 concept, right, of multiplying by -1 on the variable. So let's find out. Problem A. So we have negative x. So there's the first time we see that -1. Plus 7 equals 12. Now I've written the original equation. I think I've got it correct, so let's solve it. We're going to move the 7 to get the x by itself. The 7's going to the right, and to move a positive 7, we have to subtract 7, right? So we have to use subtraction property of equality. Negative x plus 7 minus, or negative minus 7 equals 12 minus 7. The 7's over here on the left-hand side cancel each other. We end up with a negative x is equal to 12 minus 7, which is 5. So now we have a negative x. We can't have negative x. It has to be a coefficient of 1, of a positive 1. And this is a coefficient 1, but it's a -1. So we have to multiply both sides by a -1. So -1 times minus x, or negative x, equals 5 times -1. When we do that, the two negatives here cancel, and we end up with x equals a positive and a negative is a negative, -5. There's that answer. Excuse me. Problem B, negative a minus 5 equals -8. That's the problem. I've looked at it. Yes. We're going to move the 5 because I'm going to keep the a on the left-hand side. Negative a minus 5 plus 5 equals -8 plus 5. That's using the addition property of equality. We added 2 5s. So now these 5s cancel. We get negative a equals negative 8 plus 5 is equal to negative 3. Now we have to get rid of the negative sign in front of the a because it's got to be a positive sign, as we just said in the previous problem. So we multiply both sides by negative 1. So a negative 1 times negative a equals negative 3 times negative 1. And then doing that, we get these ones cancel, which is good. We wanted them to cancel. That was the purpose. So now we get a equals negative times a negative is a positive equals 3. Let's go to the C, problem C. 4 equals negative C plus 11. We want this negative C by itself. We'll keep it on the right. I'll move the 11 using the subtraction property of equality. So I'm going to use a negative 11, right? So negative 11 plus 4 is equal to negative C plus 11 minus 11. The 11s cancel over here on the left, on the right. We have a negative 11 and 4 gives us a what? It gives us a negative 7, right? Equals negative C. So now we have to get rid of the negative on our coefficient of that C because it has to be a positive. Positive 1, not negative 1. And do that, we're going to multiply both sides by negative 1. So we're going to get negative 1 times negative 7 equals negative C times negative 1. That's a 1, by the way, right there, negative 1. Come on, little, let me clean it up. Let me clean that up. Oh, there. Put that back, put this back to here and say negative 1. Better? Yes, I think so. So now the negatives disappear here with the on the negative 7, so it becomes 7 equals, and the negative 1 times the negative C gives us a positive C. So C is 7. Okay, good job. Okay, example 4, using deductive reasoning. So it's a solve 1 equals k divided by 12 plus 5. This is really mostly no different than what we've just been looking at, but we're going to look at talking about it, the words we're using to outline our steps. Okay, so step 1, we're going to write the original equation. And it's here we have 1 equals k divided by 12 plus 5. And what we're going to say, why did we do that? Well, we wanted to write the original equation to have a starting point on our paper. Right? What if the problem was in the book? You're not going to just start answering the problem in the book. You always write the problem first and then start solving. And that's kind of what this is implying. The original equation's been written in the beginning. Then the next step, what are we going to do? We're going to remove the 5, as we've talked about, the constant from the variable side. So we're going to, in order to get rid of the plus 5, we're going to add a negative 5. So we're going to add a negative 5 to each side. That's what we have here. And what does the step say? The subtraction property of equality. We are subtracting 5, right? That's the hint. You had to use subtraction, so it's the subtraction, and it's always the property of equality. Remember that. Okay, so then now we have negative 4, because 1 plus negative 5 is negative 4, equals k divided by 12, because these 5's canceled. So now a negative 4 is equal to k divided by 12. We have to get rid of the 12. And we're going to use multiplication to get rid of that. We're going to multiply the top of this fraction by 12. That'll get rid of the 12 over the 12. 12 divided by 12 will give us 1. It will give us a positive 1, and it'll leave us with the k. So we're going to multiply both sides by 12 after we subtracted this stuff up here. We said we subtracted. So now we're multiplying both sides by 12. And how are we doing that? Multiply both sides by 12, and we're using the multiplication property of equality. And we're multiplying. So that's the property we're using. And when you multiply 12 times negative 4, you get negative 48. And when you multiply, oh, and then you end up with 12 because the 12 times 1 over 12 is a 1. 12 over 12 is 1, and we end up with cave. So negative 48. And the last thing we did is said that we multiplied. This is our deductive reasoning. Why do we do? Oh, we subtracted. And oh, then we subtracted. Then we multiplied. And then we multiplied. See, this is the steps you're learning to follow. Okay, example 4. Check your understanding. As you know, I'm going to ask you to pause the video and try this out on your own. And you can go back to the previous slide to get a hint as to what you're doing and what the words are for the reasoning. It'll all be pretty much exactly the same. Different numbers, but basically the same. Our equation is 3/5 W plus 9 equals negative 1. I'm going to wait for you, and then we'll go through these steps one at a time, okay? I'll wait for you. So give it a try. Okay, I'm assuming that you've come back, and we're going to look at these together. So let's get to what the first step is. The first step here is writing down the original equation. That's to make sure that when you're finally solving it, you don't end up with solving the wrong equation. And guess what? You get the problem wrong. That goes against your grade, all because you wrote the problem down. You did every step perfect for the problem you wrote down incorrectly. So always make sure you're working from the correct problem by writing down the original equation and then comparing it to what you were writing down. And like I said before, it always gives you the chance to think about what the problem is. As you're writing it, you say, oh, I'm going to move the 9 over here. I'm going to be dividing by this. I'm going to add that. You know, it gives you a chance to think about that as you're doing it. Okay, so now we'll go to the next step. So now, so what do we do? That we decided that we're going to put the W, we're going to leave the W term on the left, and we're going to move the 9 term. So in order to do that, we had to do what? We had to subtract 9 to get rid of the 9 on the left and add that negative 9 to the right. So that property is subtraction property of equality. We added negative 9 to both sides. Then we ended up with, after we did that subtraction, with 3/5 W is equal to negative 10, because we took a negative 1 and added a negative 9, gave us a negative 10. Okay, so then the next step after that is we had to get rid of the 5/3. Well, the 5/3, how do you get rid of the 5/3? Well, we're going to multiply. And what are we going to multiply by? Well, what we do is we multiply by the reciprocal. And the reciprocal is, as we see right here, you take the number in our case was 3/5, and you flip it. Now we have 5/3 over here. You flipped it. And so you multiply the 3/5 by its inverse. And that way the 5 times the 3 is 15. The 3 times the 5 is 15. And you end up with what? 15 over 15. And that's equal to 1. So 1 over here, 1W. And we had, if you multiply by 5/3 on one side, you multiply by 5/3 on the other side. And now we have negative 10 times 5/3. And we used what property? We used the multiplication property of equality. We multiplied by the inverse. Okay, so from there we went to the next step. And the next step says W equals what? Negative 50 over 3, because you took negative 10 times 5 and you got negative 50, and you divide that by 3. And the W is by itself. Well, we can leave it like this, but oftentimes your instructors probably ask you to not leave an improper fraction. So the next step would be naturally then to remove the improper fraction. So in order to not have an improper fraction, we'll just convert this, okay, to something that's more understandable. So the answer W is equal to a negative 16 and 2/3. Because 3 times 16 is 48, plus 2 is 50, right? Okay. So objective 2A, a continuation of our deductive reasoning discussion, says remember that an expression like 8 minus 3y can be written as 8 plus negative 3y. I've kind of talked about this in the past, I think. Using the definition of subtraction. This is the definition of subtraction. So the definition of subtraction says that a negative 3, in essence, can be written as a positive negative 3, plus a negative 3, right? So that's kind of what we're talking about here. Okay, so we're going to, an example 5, we're going to use deductive reasoning once again to try to make it form some solid pathways in our minds, the nerve endings and everything in our pathways in our brain. So let's solve this one. 8 minus 3y equals 14. And it says justify each step. That's where we're getting the inductive reasoning part. We're justifying our step, telling everybody why did we do this, and what gives us the right to do this. So the first thing is write the original equation, and we did that. We're saying 8 minus 3y equals 14. And it says that's the original equation right there. I wrote it, and it's the same. Then what's the first thing we're going to do? We're going to, in this case, they wanted us to, using the definition of subtraction, they wanted to convert this from 8 minus 3y to 8 plus a negative 3y. Okay? Because we're going to use some subtraction here. And now that we've done that, that's how we did that conversion right here, the plus and the minus. So now we say 8 plus a negative 3y plus a negative 8. Okay, same kind of a concept, equals 14 plus a negative 8. And that's the way I like to say it. I like to say plus a negative instead of minus. Okay, not that it would have been wrong. I could have said 8 plus or minus 3y minus 8 is equal to 14 minus 8. You could do that, but I like it the way it is now. And we use the subtraction property of equality for that because we subtracted from both sides. Then we said, after we do that subtraction, we end up with negative 3y equals 6. Not minus 3y equals 6. I say negative 3y equals 6. And that's because of subtraction. In order then to get rid of the 3 and to get rid of the negative 3, because we want a positive 1 with that y, we're going to multiply both sides by the inverse of negative 3, which is 1 over 3. Okay? The inverse of 3 is 1 over 3. The inverse of 1/3 is 3. It's just flip it over. Because if you say 3 is really 3 over 1, is it not? And the inverse is equal to 1 over 3. Okay? So now we have that. We multiplied using the multiplication property of equality. We multiplied each side by negative 1/3. And when you do that, the negative 3y becomes y, because the negative 3 times the negative 1/3 gives us a positive 1. So we end up with a positive 1y and equals. So 6 times negative 1/3 is 1/3 of 6 negative is negative 2. And we used the multiplication property of equality for this step, and then we just multiplied and came up with our final answer. Okay, example 5, check your understanding. And now I'm sure you all are familiar with the procedure here. When it says check your understanding, I want you to stop the video and try this on your own. I've given you a little bit of a hint where I said steps and reasons. So that's it. You told me what the steps are and what the reason was for causing the step. And it's just like the one before it, just like the previous slide. So when you stop, I guess you can go back and forth, can't you? Anyway, so it says directions. Solve -9 or -9 minus 4m equals 3, and justify your steps. So I'm going to give you some time to go ahead and do it. And then when you come back, we'll go ahead and work through the different steps together. Okay? Okay, I'll give you 5 seconds. Okay, so now that you've done that and you're back, we're going to go ahead and start moving forward. So what did I first do? I wrote out the original equation. And as I've been saying all along, always write the equation. Whether they ask for it or not, write it. The beauty of that is that as you're writing it, you're looking to see what the question truly is. You get a deeper understanding of the question, and you're starting to figure out how to solve the problem right away. You know you got to move the constants and multiply or divide the coefficients. You're looking at them and you're thinking, okay, I have a feel for this. And you also get to see, is this the exact equation that I'm being asked to solve? Because if you solve the wrong equation, guess what? The teacher's going to mark you wrong. Even if you solve the wrong equation correctly, the teacher's going to mark you wrong. So, okay, so the first thing we're going to do is we're writing the original equation. Then we're going to we see that we have to get the 3m the negative 4m by itself. In order to do that, we have to move the negative 9. And we move a negative 9 by doing what? By adding a positive 9. So if you add a positive 9 to both sides, remember the scales, whatever you put on one side, you have to keep it on the other side to balance the scales. This is the addition property of equality. We're adding 9 to both sides, and this equation will not change. It's the exact same equation. It has maybe different numbers, but the balance of the equation will not change. So now that we have that, we've added in a 9 on both sides for the addition property of equality. Then once we do that, we're going to simplify it, which means that the 9's on the left-hand side, right here on the left-hand side, bingo, gone. And the 3 plus 9 on the other side equals 12. So 3 plus 9 is 12. So negative 4m equals 12. That's what we're left with. Negative 4m equals 12. So now we have to get the m to the point where it has a coefficient of 1. Not negative 1, but 1. And in order to do that, we have to divide by negative 4. Or we can multiply by the reciprocal, which is 1 over 4. One is negative 1 over 4 in our case. Okay, so we've simplified. We've got the equation. We're moving forward. So to remove the negative 4m, to get the m by itself with a positive coefficient, we're going to multiply by, in this case, by the reciprocal of negative 4, which is negative 1/4. You take, and how do we look at that? We took it negative 1/4. If you take 4, I'm going to do it down here, 4 over 1. Remember, this is a fraction, 4 over 1. And the reciprocal is equal to 1 over 4. In our case, it was negative 4 here, the negative 4. So we have a negative 4. What's the reciprocal of negative 4? It's negative 1/4. Okay? So now so this is multiplying by the reciprocal. We're multiplying negative 4m by the reciprocal negative 1/4 on both sides. So negative 1/4 times, I'm going to put a parenthesis right here so it looks kind of more sense. How's that? Negative 1/4 times negative 4m is equal to 12 times negative 1/4. And the 4 cancels on here, and this cancels, and we're left with m, right? And the 12, what happens? 12 divided by negative 4, or times a negative 1/4, and that's going to equal what? It's going to equal negative 3. Good job.